moving ahead with the first keynote address for the day, we have Rajesh Mahapatra, Senior Engineering Manager, SCOE at Analog Devices, and he'd be speaking about navigating the future of robotics with ROS.
All right. Good morning, all of you. And before I wanted to give this talk, I just wanted to let you know a little bit about my first exposure of ROS. It was actually a few years back, and it was also a very cold morning like this today. And we were invited for a meeting. We went for the meeting, and after the meeting, there was a demo for us. In that demo, a young person, very much like most of you here, showed us a very simple demo. He ran some commands and the small robotic arms moved. Now, it's not like these huge robotic arms we see today, but it was very, very exciting for me because that was the first time I saw a physical robotic arms anywhere. And just as any engineer or manager, I immediately went back after the demo and asked, how much time did you take to build this code? How many lines of code did you write? And then he showed me a few lines of code, and he said, just took 1 month. That day, I was very impressed, and I realized what's the full potential of this ROS can be. Of course, it was many years later when we started working on ROS, and we have started contributing a little bit, which we'll see. And in the next 20 to 25 minutes today, I will take you through what is our thought process behind contributing to this market, some solutions that we have built in this space, and how we are leveraging ROS. Okay, before I open my slide, just by show of hands, how many of you know about solutions from Analog Devices in robotics and ROS? I just want to get a rough idea. Very few hands. So I'm really glad that I'm doing these slides now. Okay, so the main motivation for us is about factories for the future. We actually are from, my group is industrial automation, and our big focus is factories for the future. And we believe these factories for the future will be enabled by data and insights. For any data and insights to be created, we want something in the beginning, on the left-hand side, intelligent edge. Now, if you go and ask 5 different people about what intelligent edge is, they will give you different answers. For me, intelligent edge is something where you can capture the data, so sense, where you can measure it, where you can do some kind of computation on it to generate insights. And once you have those insights, you should be able to communicate, have some connectivity to send that data to wherever it may be processed or wherever it may be used. So that's the first part. Now, once you have these data and insights coming in, you need to be able to use it for some use. The way we envisage is we will use it to customize manufacturing. Now, there may be factories which will manufacture auto parts for the first 3 days in a week. And they may be manufacturing nuts and bolts for 2 days and do something else, maybe spray paint one car for another 3 days. So if you want to enable these kind of manufacturing, people should be able to configure them fast, and people should be able to customize to whatever their needs is. And we believe if we generate enough data and enough good insights, then this is possible for us to do, which is customizing manufacturing. And this will be done, in our view, by 2 different ways. The first one is by using configurable solutions, software configurable solutions. And the second one is by using robots that are safe, also versatile. And if we achieve this, we believe our end goal is to have sustainable manufacturing. Now, many of these companies like ADI are committed to making sure that we will contribute our part for the planet. And in our mind, at least in our group, we believe that the sustainable manufacturing can be again done by two areas which are our core strength. Now, companies will contribute in these ways, in some big ways in their own strength. For us, we feel the first one will be by efficient power. And the second one will be to making sure that all these motor controls that are happening are also running very efficiently. So with this, that's our end goal, that we want to go to a place where we can enable sustainable manufacturing, and we also want to have a big place in that. Now, knowing that robotics or robots can actually give us this productivity, just wanted to understand a little bit about, show you what, most of you know where it is, but we just wanted to talk a little bit about different applications of robots. One, you actually saw the robots being used in home for mopping and cleaning, so that was in the talk earlier. There are other places where robots can be used, but for us, our focus is industrial robots. Now, there are some big words here, so I will read it out from this. Industrial robots, a multifunctional, reprogrammable, automatically controlled manipulator, programmable in 3 or more axes that can be fixed in one area or mobile for use in industrial automation applications. Now, among these industrial robots, we don't believe that you will have any humanoid shape, but we believe that these robots will do what human beings are doing, either by functionality, the way we move our arms or something, or by behavior, but in a way that machine does, that is accurately and at a high speed. In addition, there is this 3D use of robots which I came across places, and professor actually talked about one area. Robots will get used in places that are dirty. For example, there was this example of cleaning public toilets. Then robots are actually getting used in places that are dull, meaning wherever there are a lot of repetitive things happening, and human beings can make error, they won't have that energy to run through. But a machine doing it again and again, and these robots will bring in that productivity, that effectiveness that we desire. The third thing is dangerous areas. When I say dangerous, it could be something maybe very high temperature, or it could be something where fire may break out, or it could be something where poisonous gases are in that area. So we envisage these industrial robots to be used in these kind of applications. Now, knowing what robots can do, let's look at something where ADI can actually contribute, and again, in the areas where we are good at. Analog devices is well known for its analog components, and we actually make very precise measurements. We provide very high resolution converters, and we believe these A to D, these D to A, and all the other analog components that we have will have a big play in making sure that the signals that you're interpreting for robotics application and these diverse range of signals that we have to encounter can actually be handled in these equipments. The second area where we are making a big play today is an industrial sensing. Now, we have some very good motor control solutions. Now, these give you very precise measurement of where that shaft is, and it also gives you a very precise rotation of that motion. Now, some of these can be used in the grippers. If you want to really hold on to some complex objects, then these will get into picture. In addition, there are a lot of applications where cobots are being deployed. Cobots are collaboration robot or collaborative robots. This is a case where robots and human beings act next to each other. Now, there are some things you have to make sure that, if I'm sitting here and there is a robot moving around, I don't want it to knock on my head or just kick me out somewhere, by some mistake. So there is a good amount of effort going in, and ADI also has products, our radar solution, LiDAR solution, and our time of flight sensors, which can give that sensing to make sure that these cobots can work really well. Third thing is when people are investing in robots, it is also already becoming very expensive. It gives productivity, but the investment is also very high. And we need to make sure that all these assets can be tracked for health. We have some solutions, condition-based monitoring and other solutions that can be used to make sure that these motors are working fine, all the assets are in good condition. If any repair or if any maintenance is required, it is given some message a priori. And with help of that, these factories probably can run for a very long time. And it helps in this entire robotics market. And when I was talking about this, I was also saying that if you have, let's say, 5-ton robot moving around, you don't want anyone like a hacker getting access to it. You want to make sure that there is enough security in these robots, right from the secure boot up to the operations and to the way data is transmitted to wherever that application will be. Now, we have a very strong team inside ADI which handles security, and they can help in all levels of security applications. The other thing is connectivity. Now, let's say that we have a robot with, let's say, finger kind of motion. Now, you can imagine how many joints are in this, right? And for this communication to happen across, there has to be really very fast connectivity. The industrial Ethernet that we provide, the wired and wireless, both kind of connectivity, or both hardware as well as stacks that we provide, are very useful for any kind of robotics application. Again, I'll talk about power, maybe repetition you will see in a few places, but we can't just stop emphasizing how much effect power has. Sometimes you just need efficient power, sometimes you also need that power to fit into a very small form factor. And you need to deliver power at whatever high ratings it is required. And a good solution in power makes that possible. The last one is isolation. Let's say you are working on very high voltages, then you need this isolation to make sure the systems and people are all safe. Let's look at where we were yesterday. Sort of when we started off, some of our customers bought some of our servo motors and other components, A to D, D to A, and all that. And they were basic in joint and motion. And where support kind of limited in manufacturing support. And once we realized that there is potential, we have started to work in a way where we can expand these system capabilities. And how we can expand the system capabilities is one by industrial vision. So all these things I talked about, radar, LiDAR, and time of flight, works in different kind of atmosphere. Some work very well in outdoor environment, some work very well in indoor environment, some work well in automotive kind of applications. But these gives you that vision. And this vision, as you move forward, you'll see that it will take a very big shape. And I believe there is a huge amount of potential to be exploited. We have end effectors. So I talked about that gripper. We don't have a full gripper solution. What we have is components and subsystems that can be used to make these grippers. Battery management. If you have a mobile robot, it will have battery. And there are laws in many companies, many countries, wherein if you have a mobile robot or a car, you need to have a very good battery management systems. And ADI has invested, and we are seeing the benefits of our battery management system being deployed in a wide range of applications, but in a lot in electrical vehicles. And where we envisage to move towards is somewhere where there is a constant visibility. That means when a factory is running, data is coming in all the time. If a sensor goes bad, there is no need to put the entire system offline and go and fix it. There must be data coming in over high speed and many different ways so that you can analyze what's going on and fix it without taking the entire system offline. Plus, as artificial intelligence and all these machine learning, deep learning technology gets more and more mature, they will work with these industrial sensing things what we have. We're already seeing some really good application. Today is not the time to talk about it, but you will find these intelligent perception happening. And of course, all these IMUs and other things we have can be used very well for moving the vehicle to wherever we want to move it to. This is a pictorial representation of what I talked about earlier. There is one thing there about wider perception. Now, why is wider perception critical? We ourselves have a time-of-flight device which has 78-degree field of view. And to get a 270-degree field of view, and demo of it is actually outside, we need 4 of those devices. If you can have even a 95 or 100-degree field of view, then you can cut down the cost by 25%. You can do that by 3. And this cost, you may not need it immediately, you may need some solution today, but as the system progresses, as the systems become more mature, we need to have these cost factors coming in. And this is where a wider perception will play a bigger picture. And then intelligence, of course. A lot of you, there was this talk in the art park about a big use of machine learning and AI in robotics. We also believe that will happen. And we bring in, from ADI, we have developed quite a lot of technology along with our system knowledge. And we believe we can bring that to a very good use in robotics. Now, these are some, I will say, details in kind of where we are contributing with ADI. We believe that for these factories of the future, robotics will be the front runner in that. There is cutting-edge semiconductor happening for advanced sensing, for motion control, and even as we speak, even though we have good solutions, our customers are demanding higher precision, and we are building it for them. Machine learning will come in, and it will all help in creating modular mobile thing. Now, we're not saying that ADI will focus only on the mobile thing, but we believe that a lot of the solution will go into that area. And in fact, even an earlier slide I saw among those videos, there are actually a lot of it were about these mobile robots. And you will see one example from ADI side about that mobile robot. We believe that these things will make it safer, will make it more efficient, and it should be adaptable to a wide range of applications. Now, because of this focus on this mobile robot, I will show in the next slide something about the components that go into this mobile robot. Now, any kind of mobile robot will have many other things. But again, these are some things which are crucial, and these are some things where ADI has some solutions in it. Precision motion control, where you can control these wheel drives. They are one key area for us. Efficient power management and battery management system. I talked about it earlier. They're also crucial for any mobile robot. And then I will talk a little bit more about adaptive sensing. And in that, I will talk a little bit more about time-of-flight, because this is a new product which we have come out with, a time-of-flight sensor camera with some of compute engine behind it. And for some applications like collision detection, we have run it with a radius, with a range of about 4 to 6 meters. But if you use a longer range, you can do some parameter training and get even longer, almost double that range from a time-of-flight. And because it gives you a 3D image, you can actually do some really powerful operations on it, which is not, for doing it on a LiDAR or radar, there are different sort of challenges involved in that. I will also talk about these, since many of you said you do not know about ADI solution, I'll also talk about these AI-enabled or a microcontroller which has a deep learning engine on it. This is 78,000. And if you go to the GitHub, you will see some examples of face recognition in that. You will see some examples where through audio analysis, you can count. And we have also implemented some sort of a gesture recognition. Now, we believe that this, when it is sitting next to an IMU, can do processing very fast, and we can take your robot move in the right direction in a very efficient way. And when you can move the robot faster, you can probably do things faster. Let's say in a warehouse, you are taking some components from one bin into the packing area. If the robot moves faster, I guess you can send more packages out. And then the big thing is open source. And all of these solutions that we are building today, we are committed to put a ROS interface on it. And there are already quite a few of these which are on this slide that have ROS interfaces on it. The demo that we are giving outside will also have a ROS interface, but I have some slides to talk about it later. This is our ADAM, analog devices, autonomous moped, and this is just a test bed. The form factor is not that great. E-info chips actually have a better form factor solution, including using some of our technology there. But what we want to do with this ADAM is give it to our customers to understand how these components are working so they can build better solutions out of it. This will give a real-time example of components talking to each other, of all those various things that I talked about. This will also give a platform for people to experiment. So if somebody has some really cool algorithm and they want to test it out, they can test it out on this. And in addition, it will give us insight into what are the different challenges people are facing in this mobile robot area. And on the right-hand side, there are components, I won't go through them. If you are interested, you can look up this slide and see what exact components we're using. And there are, among the technology that I talked about wheel drives, this is listed here. The processor is listed here. The few intelligent sensors that we are using are listed here. And this is one example where we have used ROS very effectively. It was very handy. I will take you through another example of safety bubble as a ROS node. So as you get more and more robots come in, as you get robots and human beings working together, there has to be a way that assets and human beings are safe. Otherwise, these machines or these factories will get banned in many countries. If factories harm human beings, I'm pretty sure it will get banned. And there will be laws to make sure that you have to do this. And one key area here is collision detection. Now, people can do collision detection in many different ways. We have taken one approach here where we will put these, let me see if it works. Yeah, okay, very thin. But we will put our robot in there in the middle, and the red circle around is kind of the danger zone. Now, if anyone enters that red zone, it should give a flag, and you can decide what you want to do. Stop it, stop the motion, or go back to the previous position, or any number of things. And the green zone is a safe zone. You can do whatever, the robot can do whatever it wants. And this zone is configurable. So essentially, you can, we have put 1 meter by default, but you can configure that in ways. This is a small video. You will see much better demo outside. But this video gives you a rough idea of what we are doing in our conference room. We put the robot in one place, put a marker saying that around 1 meter radius, and people, and some of them are sitting here in the front line, and they are walking around to see whether you are detecting. There is a small green box rectangle on the top that will turn red when somebody goes closer. And there is also visualization to say when one object is moving, what the shape of that visualization, and the color will show red if it is in the danger zone. Okay, so I thought it's ROSCon, so we'll just talk a little bit about architecture, not too much detail, but at a very base level, each of these nodes that we are using, each of these time-of-flight sensors that we are using, they are ROS nodes. And they send out all that information over ROS topics. And then we have one huge host. And the reason why we picked up this host is because we realized that For safety bubble, maybe just collation of the data. There is no real operation here. But if you really want to do image stitching, for example, I told you that this field of view is 78 degree. And if you want to have 270-degree field of view, you want to really stitch that image of all the 4 sensors that are coming in, you need good amount of processing. That's why we picked up an NVIDIA solution. And what we are doing in this big host processor for these application is that it just subscribes to that ROS topics. It takes in the data output. And if any of these 4 things are saying error or somebody in the danger zone, it will say danger. But of course, because it has the depth information, it can do some cool visualizations also. Just as for people who are interested in signal processing, people who are interested in how that data moves, on the right-hand side, we have these CMOS sensors, the time of flight. And then after that, the time of flight actually generates enormous amount of data. And if you want to really compute depth out of it in a processor, it will almost take 50%, 60% of something like IMX8. So we have come up with our own hardware solution, which will do the depth compute. So you will have the depth image available in the processor. And we are running the safety algorithm there, all the ROS related things over there. That data comes in from there, and it's a little noisy. So we do some pre-processing like any kind of applications to clarify or make it clearer. And then we run these safety bubble algorithm and push it to the host. And the host does some visualization to display it. Now, I also told you in the beginning that I will, for people who are in these robotics application, I will share some numbers that should excite you and should sort of give you a good feeling about playing in this area. So these are some numbers we got from some sprint we did in our company by looking at some reports that are available and going through some newspaper articles. Now, first one, money. Just in US alone, after the CHIPS Act was passed, $200 billion of investment has come in to invest in semiconductor, in different areas of semiconductor. There are 3.5 million industrial robots working today worldwide. And we believe that these gigafactories that are in the world today, gigafactories are factories which are investing in cool tech, in green tech, but mostly for our kind of discussion, they use very advanced robotics. We see that there will be a 4x gain in gigafactories. And of course, there is a large amount of solutions available today to make things digital and for connectivity. Putting all this together, we believe that if we play in robotics, we have a very good opportunities in the market. And these numbers should excite you too. And in the end, thank you. Going back to the story I was telling you, very long back, I met in a small group, people moving robots. Now in our company, after working on ROS and other things, we also have solutions which moves big industrial robot arms. They are tied to our Max 78000 to do, you can tell some numbers and it will move from one place to other by doing audio processing. There is gesture recognition based solutions available also. In addition to that, we have put our own GitHub and contribute to the 7,000 odd repositories which we saw in the earlier presentation. And in some ways, we also contributed in a very small way to make sure that we can all be here together and learn from each other. Thank you.